Hello, my name is Dave Buckley, and today we're going to talk about data acquisition units and particular data sources that you find on data acquisition units. In general, there are two types of data sources that you will see in your data acquisition unit, or DAO. There is synchronous data sources, and these are data sources that are under control of the data acquisition unit itself. So they are typically samples of data that repeat periodically. This will be an analog channel such as an accelerometer or a strain gauge, or even a discrete channel that captures some sort of bi-level input. And the data acquisition unit itself will control the sampling of these channels. So at equal intervals, it will sample the channels and it will gather the data and transmit it out so that it can be analyzed. The second type of input is asynchronous. Now, these channels typically are not under the control of the data acquisition unit, so data will arrive at an asynchronous interval to the DAO itself. So where you have even samples in the synchronous system, you will very often have uneven spaced samples arriving in the asynchronous system, like such. So there are the two types of sources of data that you typically find in a DAO. Now, it's very important for the sake of post-flight analysis and correlation of parameters that every single data source in the DAO can be correlated, so you know the time when each sample was taken. If we take the synchronous example, you want to make sure that the sampling of the channels occurs at the same time for all channels. However, you may have a situation where you're sampling different channels at different rates. If we look at an example of this and take a 1 Hz signal, a 2 Hz signal, and maybe a 4 Hz signal, you will see that each channel gets sampled at a different rate. But if you take the first sample from each channel and sample it at exactly the same time, you will see that the pattern repeats over and over again. And if you take the superset of all the samples, what we describe as an acquisition cycle, and you follow the sampling schema, you will be able to very easily correlate the samples from each channel together and know exactly when they are sampled. If you then took an asynchronous source and compared it to what was going on with the synchronous data, you will find, as mentioned before, that you are not under control of when the messages arrive. They may arrive at unexpected intervals, so all you can do is monitor the bus and wait until the samples arrive. If you then want to correlate these asynchronous samples with your synchronous samples, you need to timestamp exactly when these arrive. So this sampling schema here will be timed to an absolute time known by the DAO, and you will use that time to put timestamps on your asynchronous traffic. And then by comparing these timestamps against the known timestamp for the overall synchronous traffic, you will be able to correlate everything in your system together.